What new discoveries are waiting out there? What new adventures can we see? What are the answers to the never-ending questions in your brain that's in a race to find the reason or the place from defined word to outer space, so that the truth of any case can be unfurled in the real world. Science in the real world.
Hi, I'm Kirsten. Welcome to Real World Science. Today, we're going to explore a strange and invisible force that affects everything on Earth. It's called magnetism. What is magnetism? When you think about magnets, what comes to your mind? Maybe you imagine that magnets that hold pictures and notes on your refrigerator. Or maybe you're familiar with magnets on the tips of screwdrivers that can hold a screw before it's driven into place. Magnets are used in other places too, in things we use every single day. For example, a doorbell uses a magnet. So do computers and televisions. Today, magnets come in a variety of different shapes and sizes, including bar magnets, disc magnets, and horseshoe magnets. But no matter what its shape or size, every magnet has two ends called magnetic poles. One pole of the magnet will always point north, as is labeled the North Pole, and the other pole is labeled the South Pole. All magnets exert a force we call a magnetic force, or magnetism. You can't see magnetism, however, you can feel its effect. Attraction and repulsion. Magnetic forces can attract materials made from iron like paper clips and nails. However, magnets don't always attract each other. Let's demonstrate with these two disc magnets. We'll place one magnet on this pencil with its north pole facing up, and we'll place a second magnet on the rod with its north pole facing down. Watch what happens. The magnets push each other apart or repel each other. The rule for magnetic poles is that like poles repel each other, while opposite poles attract. Watch what happens with the north pole of one magnet is placed near the south pole of another magnet. The magnetic force pulls them together. Opposite poles attract. The force or repulsion and attraction can also be demonstrated using two iron magnets and iron filings. First, dip the north pole of the magnet into the iron filings. Then dip the north pole of the second magnet into the filings. When you bring them together, you can actually see the filings pushing away from each other. Next, we're going to dip the north pole of one magnet into the filings and the south pole of the second magnet into the filings. When you put the two opposite poles together, notice the filings pulling towards each other. That's the power of magnetism. Like poles repel, and opposite poles attract. Magnetic forces. Magnetic forces are the strongest of each of the magnet's poles. However, magnetic forces can be felt all around a magnet. As a matter of fact, an invisible magnetic field surrounds every magnet. The magnetic lines of force can be demonstrated by using iron filings, a bar magnet, and a plastic lid. First, place the plastic lid over the magnet. Then, sprinkle iron filings on the lid. The filings mark out the magnetic field around the magnet. As you can see, magnetic fields go around in complete loops from the North Pole to the South Pole of the magnet. Magnetic lines of force surround the Earth as well. That's because the Earth is a giant magnet. The Earth acts like it has a giant bar magnet buried deep within it with a north and south pole, and an immense magnetic field surrounding it. Why does the Earth act like a giant magnet? Scientists don't completely understand why, but most believe it is related to the makeup and motion of the Earth's inner core, which is made up of mostly iron and nickel. Today, we use a compass to determine the direction we're traveling. A compass is a device that has a magnetized needle that is allowed to spin freely. The needle of a compass will always point to the magnetic north pole of the Earth. The poles of the magnet were labeled north and south to describe the direction they faced with respect to the Earth. However, there are 2 north poles and 2 south poles. There are the geographic north and south poles located at the top and bottom of the Earth. The magnetic north pole is located in northern Canada, approximately 1,500 kilometers from the geographic north pole. The magnetic south pole is located near the coast of Antarctica. Does magnetism exist only on Earth? The answer is no. Scientists have detected magnetic fields throughout our galaxy. Besides Earth, the planet Jupiter has a magnetic field 10 times greater than the Earth's. And Saturn too has a strong magnetic field. Another source of a magnetic field in our solar system is the Sun. The Sun's magnetic field extends far above the Sun's surface. It's interesting to note that the Sun's outermost layer, called the corona, actually traces the shape of the Sun's magnetic field. And that sunspots, which appear as dark spots on the surface of the Sun, are actually where magnetic lines of force have broken through the Sun's surface. Sunspots always appear in pairs, each one of the pair representing the opposite poles of a magnet. Magnetic fields. Let's talk about magnetism and how it affects objects on Earth. We already know that magnets don't attract everything towards them. For example, if you place a magnet near a pencil, nothing happens. The same is true with a rubber eraser and a plastic ruler. However, put the same magnet near a paperclip or a screw and a nail, and they stick like glue. Why do some materials have strong magnetic fields and others don't? Well, it has to do with the atomic structure of the material. All matter is made of atoms. An atom is made up of a nucleus found at the center of the atom. Protons are nuclear particles that carry a positive charge. Orbiting the nucleus are electrons, which carry a negative charge. All of the electrons spin as they orbit the nucleus. The moving electron causes a magnetic field, making each atom a tiny magnet. In most materials, like wood or plastic, the magnetic fields of the atoms point in random directions, making the magnetic field weak, so it's barely detectable. Some materials, however, have clusters of billions of atoms all lined up in the same direction. This is known as a magnetic domain. In an object, such as a magnetized iron bar, all or most of the domains are arranged in the same direction. If a material can form a strong magnetic domain, it can make a very strong magnet. A material that shows strong magnetic effects is called a ferromagnetic material. Ferromagnetic comes from the Latin word ferrum, which means iron. Magnets can be made from any ferromagnetic material. One way to make a magnet is by placing the non-magnetized material in a strong magnetic field. This can be demonstrated by placing a ball bearing on a magnet and then adding additional bearings. They become magnetic while they are inside a magnetic field. When you remove the top bearing and move the magnet away, the other ball bearings fall one by one. Another way to make a magnet is to rub non-magnetized material, like this nail, with one pole of a strong magnet. This causes the domains in the nail to line up in the same direction, and the nail acts just like a magnet and can attract objects like a paperclip. We can use iron filings to demonstrate magnetic domains and how materials become magnetic. See how the filings are arranged randomly in the tube. When we rub one end of a magnet in the same direction several times, you see the filings are now arranged differently. They're all going in the same direction. The iron filings model magnetic domains. Some metals are easy to magnetize, like paperclips, but they lose their magnetism quickly. They're called temporary magnets. Other harder metals are more difficult to magnetize, but they tend to stay magnetized, like this bar magnet. They're called permanent magnets. Permanent magnets can become demagnetized too. By striking them hard or dropping them, domains can be knocked out of alignment. Heating a magnet can also destroy its magnetism. It's also interesting to note that if a magnet is cut in half, it creates two smaller magnets with both a north pole and a south pole. Magnetism and electricity. Another source of magnetism can be found in a wire that carries electricity. It was discovered by Hans Christian Ørsted, a Danish scientist. He noticed that when a compass was placed by an electric wire, that the compass needle would change direction when electricity flowed through the wire. He deducted that since the compass needle was only deflected by a magnetic field, that an electric current produced a magnetic field. Ørsted's experiment led to a critical scientific discovery about the relationship between electricity and magnetism, known today as electromagnetism. Scientists soon realized that if wire was twisted into loops or coiled, the result was a strong magnetic field in the center and at the two ends, which act like the poles of a magnet. A coil of wire carrying an electric current is known as a solenoid. It was then discovered that if you placed a piece of ferromagnetic material in the middle of the solenoid, the magnetic field became even greater. A solenoid with a magnetic material like iron inside is called an electromagnet. An electromagnet acquires its magnetism when the electricity is turned on and loses it when the electricity is turned off. Electromagnets are very strong temporary magnets. So electricity can produce magnetism, but can magnetism produce electricity? The answer is yes. Scientists discovered that electricity is produced in a wire when that wire passes through a magnetic field, setting up magnets with the opposite poles facing each other. We can create an electric current by quickly moving a wire through the gap between the magnets. This meter will detect the current. It doesn't matter if you move the wire or the magnet, it's the movement of the wire in relation to the magnetic field that creates the current. The magnetic field is said to induce an electric current in the wire. The process is known as electromagnetic induction. Today, we benefit from understanding the relationship between magnetism and electricity. In this program, we learn that the Earth is a really giant magnet, and that a magnet attracts objects made from iron. Magnets have a north and south pole, and opposite poles attract, while like poles repel each other. We learned how to make magnets, and about the important relationship between electricity and magnetism called electromagnetism. Magnetism, though it's invisible, is a very powerful force that exists throughout the universe. Now that science has learned how to harness and use its power, magnetism has become a very important force that makes our life better in the real world.